You are sitting at your desk, chewing on a pencil, and reading your textbook. As your eyes scan the highlighted paragraphs, you nod along. The concepts make sense. The vocabulary is familiar. You close the book feeling prepared. Then you sit down in the exam room. You look at this test paper. There is a question, followed by a massive, intimidating stretch of empty white space, and your mind goes completely blank. You've just fallen into a specific biological trap. Your brain confused perceived knowledge with real knowledge. In cognitive psychology, this is the difference between recognition and recall. Look at this comparison. On the right, a recognition activity provides a list of steps. The correct answers act as environmental prompts, triggering your memory. On the left, a true recall activity strips those prompts away, forcing you to generate the information entirely from scratch. Perceived knowledge relies on external clues. When those prompts are removed, the illusion of competence often vanishes. A failed history test is frustrating, but this psychological trap is a serious problem in high-stakes training. Think about learning emergency CPR. This standard digital learning module for CPR presents a virtual patient, asking the user to click the correct action from a tidy list. By providing the answers, it exclusively tests recognition. It completely bypasses the procedural recall required to actually perform trust compressions under pressure. You might score a perfect grade on the digital quiz, but when an actual medical emergency demands physical action, that screen hasn't trained the required muscle memory. The training is functionally useless. Before you can permanently store any fact, that information must survive the strict biological bottleneck of your working memory. Working memory acts as a gatekeeper with severe capacity limits. It can hold roughly 7 items at once, and if incoming data isn't immediately significant, your brain discards it to make room for whatever happens next. To bypass this limit, your brain relies on chunking. This is the process of grouping isolated, discrete facts into larger, logical categories. If someone hands you a massive, unformatted list of instructions for baking an apple pie, your working memory overloads. But if you chunk that list into 4 categories, prepare dough, make filling, assemble, and bake, the information becomes manageable. Information that isn't grouped and assigned significance is often erased before it ever reaches long-term storage. If information does survive, it moves into long-term memory. Think of this space as a massive mental closet, where data is organized onto shelves built from associations. Cramming with flashcards places a single fact on an isolated shelf, leaving only one path to find it. But building multiple associations, tying facts to sensory details, concepts, or experiences, constructs redundant paths to the same destination. Your ability to retrieve that information depends on the condition and contents of the shelves it's stored on in your mental closet. The environment in which you study actually becomes part of your association with the material you are studying. Because the physical surroundings act as a retrieval shelf, studying in a noisy, windowless classroom can be more effective for an exam than reading in a peaceful park. Your brain links the data to the room itself. While we can sometimes match physical locations, the single most difficult context to replicate during training is the emotional state of the learner. Imagine a conflict resolution seminar. The room is calm and the advice sounds rational. But a week later, you face a hostile, screaming employee. That intense stress floods your system with adrenaline. This triggers automatic biological responses that can block access to the intellectual knowledge you acquired in that quiet, placid environment. The gap between knowing the right thing to do and actually doing it is widest when the emotional context of your training contradicts the reality of the situation. To ensure knowledge survives, we must design the learning experience backward, starting from the exact moment the skill will be used. One of the most effective tools for this is episodic memory, our biological framework for storytelling. Stories provide a pre-built structure for our brains. Because we already understand concepts like a beginning, middle, and end, or the logical sequence of a character's bad day, the information organizes itself as it arrives. It fits into the storytelling shelves we've had since childhood, meaning we don't have to expend energy building a new organization for every new fact. When the required skill is physical or high pressure, we bridge the gap between recognition and actual recall through in-context learning. High-context training looks like this. These learners aren't clicking a mouse. They are matching the physical space, posture, and resistance of a real-world emergency, actively building the muscle memory required to save a life. If you can't physically relocate the training, you can simulate the environment's emotional pressure. Applying strict time limits or engaging in intense role play mimics the stress of the real world, forcing the brain to practice retrieval under adrenaline. Building multi-sensory, context-rich pathways ensures you can retrieve your knowledge exactly when it matters most.